Welcome back, it's Lecturer Joe again, and we're going to continue our little lesson here on basic electrical theory. Okay, here's our basic circuit. We've got a battery over here. The large stripe is the positive, the small stripe is the negative, so the electrical flow is going to be around this direction, from positive to negative. And the flow is going to come along this wire through this resistance, along to here, and then it's going to branch, split through each resistor, flow down, and then recombine through the last resistor and back. So we're going to put some values on these resistors. So we're going to say this resistor here is 1 ohm and this resistor is 2 ohms. This resistor we're going to mark off as, let's say, 7 ohms, and this resistor as 12 ohms. Now if we knew the voltage of this battery, we could do some quite complicated calculations to work out how much flow there is in the circuit, but we don't know the value of the battery. What we do know, because we've put a little flow meter in here, so we put a little flow meter there, and we know that this flow rate here is 3 amps. So there's a flow rate down through this single resistor of 3 amps. Now, just knowing that one value, we should be able to work out, with what we've learned so far in lessons 1, 2 and 3, the flow rate down through this resistor, and the flow rate here, and the flow rate here, and the flow rate here. We've learned enough in the lessons so far, just by thinking about the rules that we've covered, to figure out, if we know this is 3 amps, we should be able to work out this, this, this and this. So now's a good time to pause the video, have a think about it, talk with your colleagues, see if you can work it out. Remember, you don't need to use any equations here, we're just figuring this out by thinking about it and thinking about the rules we've covered so far. So let's take a look. The only thing we know is that we've got a flow rate of 3 amps down through this resistor, and that flow comes from what flows in here. This flow splits, and some goes that way and some goes that way. Now think about what this means. We've got 1 ohm of resistance here and 2 ohms of resistance there. Think about those in terms of being pipes with water flowing through them. Think of the whole system as being a system with a pump here and water flowing through pipes. Which of these two is the thick pipe and which of these two is the thin pipe? Remember, we said that a thick pipe, it would be easy for the water to flow through, and a thin pipe, it's more difficult. Well, here we've got the high resistance, 2 ohms, that's higher than 1 ohm, so this must be like a thin pipe, and this must be like a thick pipe. Thick pipe, easier for the water to flow through, just 1 ohm of resistance electrically. Thin pipe, harder for the water to flow through, 2 ohms of resistance electrically. So if we have got 3 amps flowing through the easy pipe, the pipe where there's only 1 ohm of resistance, then there must only be half of that flow rate on the other side, because it's twice as hard to flow through that side as it is to flow through this side. So knowing at the start that there's 3 amps of flow rate here, we can say for sure that here, where it's twice as hard to flow, there must be just 1.5 amps, because both of those come from the same flow here, where it flows in, and then they recombine to flow out. Now, having worked that out, we now know that what flows here and here must join up to flow here, so this flow rate must be 4.5 amps. And similarly, what flows here must have come from here, so this flow rate must be 4.5 amp, and this flow rate must be 4.5 amp. So a flow rate of 4.5 amps comes along, flows down through here, Splits, most of it goes through the easy path, just 1 ohm of resistance. Only half as much goes through the more difficult path where there's 2 ohms of resistance, and it recombines the flow at the bottom. So here's an example you can try for yourself. Again, we've got the battery here, positive, negative. The flow is going to be clockwise. We've got a set of 4 resistors connected up in a network, and the flow comes along, splits through these 2 resistors, recombines and carries on around to the negative. And the only thing we know is that the flow rate here is 6 amps. And from that, we should be able to work out the flow rate here, 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 and here. So have a go at that on your own.